guys, welcome back to the RT Clinic. Today I'm going to show you a little bit about advice we're using a lot here in the hospital. There are a lot of good nurses here and therapists out there. This is our heated high flow cannula. It's the Max Venturi. Is what the actual Max Tech, Max Venturi is also called. But generically it's known as a heated high flow cannula. Well, what the heck is a heated high flow cannula? Well, our standard cannula, delivers flows up to 6 liters per minute. We have high flow cannulas that go up to 15. This cannula actually delivers anywhere from 10, don't usually run that low, it's usually 20 up to 60 liters per minute. You wonder why in the heck do I need to deliver so much flow to my patient? Well, it doesn't just deliver flow, and it goes via nasal cannula, and I'll show you the special device that it's up with. But it delivers that increased amount of flow, and it causes a couple different things. The flow will go in and it'll actually wash out anatomical dead space in the airways. So your patients are having trouble ventilating, COPD patients having trouble ventilating, this will actually help them by washing out their anatomical dead space, because 40 or 50 liters per minute is a lot of flow going in and out of their airways. So it's washing out the CO2. It also is going to cause a small amount of or CPAP. So that's going to recruit alveoli and help oxygenation. So you see there's two options here. You're going to have decreased CO2. Now it's not going to do it to the same level that a BiPAP is going to do, or obviously a ventilator. It's going to get rid of some CO2, but it's also going to oxygenate the patient. So let me show you how it works. It's a little bit funky how it works, and I'll show you how I actually hooked up myself. So this is a very simple system. 100% oxygen comes in from this line right here, into this unit right here. It comes into the back, into this flow meter. This port right here is actually where room air is brought in. We're going to put a filter on it, so we don't bring any dust. We put a filter on it. So right now I'm going to turn it on. There's a little on-off switch here in the back. Here. You can hear it start to run. And I'm going to turn on here my oxygen cell. Now, I did make another video, which I'll be attaching in the comments of this to show you how to calibrate this cell. Right now, I'm not going to worry about that. But the oxygen is coming in the back through the flow meter. Room air is being brought in. You hear a change of sound when I include that. You wouldn't want to include that on the patient because that's going to decrease the amount of room air coming in, therefore take down your FiO2. So, and you can see your oxygen, sorry, not take down, it's going to increase your FiO2. And you can see that happen with our CO2, with our oxygen cell. So room air coming through here, mixing with oxygen, giving you the percentage going out to your patient. So right now, you see we're running, you go middle of the ball, so that's about 35 liters. On the side here, you're going to see a couple different adjustments. Now, we always adjust, we adjust our flow first, and then we titrate our oxygen. So what we're going to do is find the flow that's most comfortable for the patient. And they will tell you. We usually start about 30 and we increase up until, usually I'm shooting 45 to 50-ish is our goal. And once we hit that, then we will adjust our oxygen. So the flow is the bottom one. We adjust that first. Then we adjust the oxygen. So we change the oxygen a little bit, whatever they need, but that flow is most important. So we're going to change the oxygen if we need. So even though they're getting, in this case, 40 liters, we know they're getting exactly 41, 42% oxygen. You can't do that with a standard cannula because, and you think about your patients, this is going to work well, and this is our COPD patients that we're trying to not give them an excess amount of oxygen because they could be hypoxic drive type of patients. So they can run off a hypoxic drive, but that's a whole different conversation. But we limit the amount of oxygen we get to target those low saturations, 88 to 92, or the physician orders in that case. So, oxygen coming in again, room air coming out this right here. So we got 40 liters coming out of here, about 41% oxygen. It goes through a heater. In this case, we have an FEP plate heater. We'll run this, and we actually put fluid on it also. We'll run it on invasive mode. Invasive mode is 37 degrees. So this is going to heat up just like a vent circuit. The cool thing is, the number one way to troubleshoot these vent circuits, this one right here that plugs in is actually it's the wire inside the vent circuit. These four probes right here are just temperature probes. So these regulate the amount of temperature at the plate, and then they're put on the heated wire. So These are just monitoring, and these are adding heat to plate as is. So if this thing would be cold, like let's say it's halfway, partway sticking out like that, it's going to send feedback back to the heater and say, hey, it's too cold out here. The heater's going to crank up and get a lot hotter. But then when it gets out here, it figures out, oh, it's not that hot. So that's when you get a lot of rain out. So number one way to stop rain out is to fix this distal temperature probe. Make sure it's in there correctly. Super easy fix. Almost all RTs know it. It's number one way to fix any kind of rain out with these type of circuits. But this is going to hook to a little bit different device. So this is a ResMed. ResMed AccuCare high flow cannula. This is a large one. You can see this is some really nice stretchy material on here. And this is going to plug into this right here. So right now, coming out of this, these two prongs, and these are large. These aren't your standard prongs. It's 40 liters per minute and about 48, got a little bit of back pressure. It's about 50 or so, 51%. So that's what we're targeting. I'm going to put this on myself. I'm going to show you what it looks like on a patient. It's going to feel a little weird if you've ever worn one of these before. Now, this is what's going to be a little bit different about this one than on your patient, because I do not have the heater turned on. And that's kind of important, because that is the only way we can deliver this high of oxygen flow. So this is what it should look like. Like this. This little piece right here kind of takes the tension off of it a little bit. And it goes on your patient. Now what they're going to feel is they're going to feel a pressure right in the oropharynx. It actually feels like a little bit of, I feel like CPAP. And it almost chased my voice a little bit. You can hear my voice now, and now you can hear my voice a little bit more nasally. So this is the heated high flow cannula. Now what allows us to deliver such high flows? It is all about humidity and being at that 37 degrees Celsius and 100% saturated with water, just like we would in a tracheal tube. Because research has shown that if you do that with the air, you heat it, humidify it, it actually causes all your mucociliary escalator to work appropriately. But if you blow dry air in at 40 liters per minute, like I'm doing right now, it like locks up my cilia. So, and then it's going to pull moisture in because it wants to heat and humidify that air. Where's it going to pull moisture from? Absolutely pull it directly from the airways and the mucus, making a big nasty mucus. You don't want that. So what allows us to deliver these high flows? It's right here, heating and humidifying the air. So it's extremely important. You can't just run 40 liters to anybody. And this is starting to get a little bit, not necessarily painful, because I don't sound like a real wuss, but it doesn't feel comfortable. I'll say that right now. So anyway, this is what it would look like on a patient. The problem is it's not reportable because it has to run into the oxygen outlet, so you really can't run it off the tank. So run a tank out really fast. So anyway, this is how it goes. If this patient's having some shortness of breath, and I'm going to take this off just because it is ripping me up. It's got heat on it. So patient's having some shortness of breath, but their saturation is normal. We're going to come and look at this thing right here. We're going to turn this one, which is our flow, the bottom one. So you're going to see my flow go from 40, let's say 45. That's going to feel a little different. You're going to see when I change the flow, it's going to change my FiO2. So after it normalizes, I'm going to adjust my FiO2 for what I was looking for before. So flow and then oxygen, flow and then oxygen. So like I said, there are other YouTube videos going to talk about calibrating that side over there. You can go up to about 50 or 55. You're going to be washing out more CO2 with this, so that's really important. So for these COPD patients, especially if they're retaining some CO2 and they want to come off their BiPAP, it's nice to run one of these for a while. It's going to flush out their anatomical dead space, flush out their alveoli, and therefore get rid of CO2 they have. So a couple keys: heating, humidifying, starting with flow here, and then doing FiO2. And what this is going to do is going to meet and surpass their inspiratory flow demand, which makes it a high flow oxygen device. And it really bridges the gap in a lot of our COPD patients. So heated high flow cannula, used a lot. And you're going to see it way more on the nursing floors in the coming years. Vapotherm is also another type of cannula that does the same thing. A little more expensive setup, a little bit more bells and whistles. It does really similar to what this does in the same concept of delivering those high flows, heating, humidifying it, washing out dead space, adding peak, and then also ventilating and oxygenating our patients, and really bridging the gap between them wearing BiPAP and heating, maybe taking the BiPAP off the rest of your face a little bit, but it really bridges that gap in a lot of your patients, and it's an oxygen device. A lot of times, it takes a simple doctor's order, and in some cases, changing an oxygen device is just titrating for, if you've got a SAT to titrate for, you can move to a device like this. So it gives your patients a lot of comfort, gives them a rest from their BiPAP mask, and possibly gets them over the hump so they don't end up on the ventilator. So thanks for watching. Any questions, comment below. This is the heated high flow cannula. This is from Max Venturi, made by Max Venturi. I don't think of